Hello everyone, how are you? I hope you are all doing well. So in today's lecture, we are going to study instantaneous velocity. Okay, so before going to instantaneous velocity, we should know about average velocity because the concept of instantaneous velocity is somehow related with the average velocity that we study. Okay, so then it comes in our mind that what is average velocity then? Okay, so average velocity is the total distance traveled divided by the time taken to travel that distance. That is called the average velocity. And when we take we can say the time difference to the time difference tending towards to zero, then it becomes instantaneous velocity. And as its definition says, the definition of instantaneous velocity, it is the velocity at any instant is called as instantaneous velocity. For example, for determining the average velocity, we require a time interval, like the average velocity from 2 seconds to 4 seconds. Let's say average velocity from 5 seconds to 10 seconds. These kind of time intervals are taken to determine the average velocity. But in case of instantaneous velocity, we don't require any time interval. We require only particular one time or we can say at particular one instant on which we want to find out the instantaneous velocity. Let's say velocity at 2 seconds, velocity at 5 seconds, velocity at 7 seconds. These kind of uh, we can say data points can be taken from the instantaneous velocity. So before going to instantaneous velocity, let's hand on to the average velocity. So let me write. So first of all, it is average velocity. And how do we define average velocity? It is basically denoted by V bar, and it is given as delta x over delta t. And one more thing I want to tell you that we are going to study instantaneous velocity this time in 1D motion. Okay, so let me mention somewhere so that you will not get confused. Here we are studying 1D motion. Or the second name we can tell it is the motion in a straight line. Motion in a straight line. Okay, so for this average velocity is given as delta x over delta t, and where the delta x and delta t is nothing but here the delta x is the position at time t2 minus position at time t1. That means x2 minus x1 upon t2 minus t1, where t1 is the first uh, we can say the first instance from we are going to find out the average velocity, and t2 is the final point. So that's how we give the average velocity. Now we will move to the instantaneous velocity, how to find out the instantaneous velocity when we know the average velocity. Okay, so this time the instantaneous velocity will be given as, let me write, instantaneous, one second, instantaneous velocity, and it is denoted by v only, or we can say it is a function of time, then it can be written as v of t. That's how we denote the instantaneous velocity. So velocity at any instant can be written as velocity, the velocity at an instant, or in place of instant we can write time t. At an instant is called instantaneous velocity. Instantaneous velocity. And it is denoted by, and it is given by, mathematically we can write it as, mathematically it is given as v equals to limit of delta t tends to 0, delta x divided by delta t. That means here the limit of time interval delta t is going to be 0. For example, for finding out the average velocity, if we are taking the time interval as 2 seconds, like from 3 seconds to 5 seconds, and then we are going to reduce the time interval as like from 3.5 to 4.5, like the time interval of 1 second. That's how we will be going to 0 seconds, like 0.001. When the value of delta t becomes 0.001, or nearly approximate to 0, then it becomes instantaneous velocity. That means the time interval is it will be going to approximately 0. Fine. And, or we can say that when delta t is infinitesimally small, when delta t is infinitesimally small, then we can write that velocity, instantaneous velocity v equals to dx over dt. Fine. That's how we can say find out the instantaneous velocity by using the concept of average velocity, and where dx over dt is nothing but the time, uh, the differentiation of the position, the given position of any object with respect to time. That is instantaneous velocity. Okay, so for getting more into the detail, let's take one example. From that we can understand more about the instantaneous velocity. Let's say example we are taking. Okay, an object is moving in positive x-axis, such as the its position is given as x equals to 5t square plus 10. This is the position of the moving object in towards the positive x-axis, and it is measured in where x is measured in meters and t in seconds. where x is measured in meters and t is measured in seconds. That means t is time and x is the position of the object which is moving towards the positive x-axis. Now our task is to find find the instantaneous velocity, instantaneous velocity of the object at t equals to 5 seconds. At this point, we are interested to find out the instantaneous velocity. Now let's try to find out its instantaneous velocity. How to find out that we all know. Just now we have derived the equation of instantaneous velocity. Okay, so what is that? When the the position of the we can say object is given as a function of time, then we can directly differentiate it. Okay, so first of all, we'll write the position of the object is x equals to 5t square plus 10. Okay, so now the instantaneous velocity will be now the instantaneous velocity is v equals to dx over dt, dx divided by dt. That means we are differentiating the position with respect to time t. Okay, v equals to d over dt 5t square plus 10. Now we will apply just the rules of differentiation. So, okay, so for your better understanding, I'm writing the, we can say that in between steps also, so that it will be easy for you to understand. Del over dt, d over dt 5 t square plus d over dt, it is acting on 10. So v equals to, here we can see that 5 is a constant, so we can take it out of the differentiation. So it will become 5 d by dt t square plus, since 10 is a constant, so the differentiation of constant is 0. Now the next step will be v equals to 5 into, since here the power of time t is 2, so 2 will come before to the variable, and now the power of variable will become uh, -1. So it will become 2 minus 1, that will be 1. No need to write that. Okay, so the instantaneous velocity is v equals to 10t. So that is the instantaneous velocity of that particular object at any time t. Okay, and we can name it as instantaneous velocity at any time t. Fine. Now we have been asked to find out the velocity at time t equals to 5 seconds. So let's place the value of t equals to 5 seconds. Then we will get that since t equals to 5 seconds. So the velocity will be at 5 seconds, it will be 10 into 5, and the unit will be meter per second. So the instantaneous velocity at 5 seconds is 50 meter per second. That is the instantaneous velocity of the particular object that was given in the question. Okay. So that's how we can find out the instantaneous velocity by using the numerical method. Now there is another method to find out the instantaneous velocity, and you'll be going to see that which method is easy. This one is called as numerical method. Now the another one is graphical method. By using the graphical method also you can find out the instantaneous velocity. Then we will see that how to find out that. Okay. So in graphical method, let me write. Okay. Graphical method. In graphical method, how to find out the instantaneous velocity. So what we take simply the tangent, the slope of the tangent, the slope of the tangent to the position versus time graph, position versus time graph at the given instant is instantaneous velocity. Instantaneous velocity. Okay. So now we are going to see that how to find out that actually. So for that we need a graph. So let's draw that. One second. Okay. So let's say the horizontal axis is given as, it is given as time axis. Okay. The time t is taken as the horizontal axis. And on the vertical axis, we are going to use x. Fine. And let's say there is we can say a graph is given, and it is drawn like this. Okay. So for this particular graph, if we want to find out, let's say some points are also given on the x-axis and y, on the we can say horizontal axis and the vertical axis, and those points are mentioned as, say it is 0, then 1, 2, 3, 4, 5, 6, and time is measured in seconds, and it is measured in meters. And let's say it is 2, then it is 4, 6, 8, 10, and 12. Likewise, the on the vertical and the x-axis, on the horizontal axis, the scaling is given as. Okay. And now we want to find out the instantaneous velocity at 4 seconds. So how to find out that? First of all, we will be going to comparing the average velocity with the instantaneous velocity. Then you will get the more exact idea about the graphical method. So let's say we are finding out here the average velocity uh, between 3 and 5 seconds. Valid. Okay. So between 3 and 5 seconds, here it is 3 and here it is 5. Fine. So what we have to do is we are going to make the line P1, P2. Okay. And the line will be from P1 to P2. Likewise. Okay. It is not the exact line. Let me draw it again. From P1 to P2, like it is okay. You can assume like it is a straight line. And then we are going to find out some velocity, average velocity, okay, at that particular point, and that will be x2 minus x1 divided by t2 minus t1. And this time delta t, that is t2 minus t1, is 5 minus 3 equals to 2 seconds. So we'll get some velocity, but that will not be the instantaneous velocity. So when we reduce the step size, that is the time difference to less than 2. So let's say it is 3.5 to 4.5. T1 and T2 are the values such as. So this time delta T will become as 4.5 minus 3.5 and it will become as 1 seconds. Fine. And if the time interval is 1 second, then again we are going to find out the average velocity x2 minus x1, that is t2 minus t1. Now we are and one more thing, we can again draw the line between 3.5 and 4.5. So this will be the line. And when we reduce the step size, the steps will be taken, more steps will be taken. And when the delta t is equals to 0.01 second, then what will happen? Then we will get the points just near to this point 4. Okay. And at that point, or we can say at that instant, we are going to get a straight line that is called the tangent to the point 4. So at that particular point, we are going to see a tangent to the point 4. So at that particular point, there will be a tangent. And now, as per the definition of the graphical method, the slope of that tangent will be going to our instantaneous velocity. So that's how we can find out the instantaneous velocity, by finding out the slope of the tangent at the particular given point. So instantaneous velocity will be again this time also delta x over delta t, and the limit of delta t is tending towards to 0. So that's how we can find out the instantaneous velocity. I suggest you to use numerical method whenever you are dealing with the instantaneous velocity. Use only numerical method. It is way easier than the graphical method. Because in numerical method, you are going to differentiate the position of the given object or any particle which is moving. Fine. And if the, we can say, the position of the object is given as a function of time, then definitely you should use the numerical method. And when the we can say the expression or any equation of the position is not given and you are only given the data points, then there is we can say no choice. You have to use the graphical method you have to plot the graph, and then you have to take the tangent to the tangent at the particular given point, and the slope of that tangent you have to find out, and that will be your instantaneous velocity. So that's all about the instantaneous velocity. And if you still have any doubt, then you can ask me in the comment section. So I'll try to resolve it there, or if I will not be able to resolve it there, then definitely we will discuss it in the next video. Okay, thank you.